Hey guys, welcome to day 7. Today we are going to be reviewing solving one-step equations, and we are only going to focus on addition and subtraction. So please go ahead and start writing in your notes your title. Your date for today is April 7, 2020. And let's go ahead and start with the vocabulary of the day. Remember to pause the video as needed. You do not have to follow along with me as fast as this is going. So pause the video and let's discuss the vocabulary of the day. So today we will be using the following terms. The first term is a variable, and a variable is a letter in place of a number. We will also be using the term balance beam, and a balance beam is a tool used to balance two different things, and you're going to go ahead and see why a balance beam is important. We're going to be using the word inverse operation, and an inverse operation is the operation that reverses the effect of another operation. So for example, addition and subtraction are inverse operations. We're going to use the term isolate, and isolate means to leave alone. And lastly, the term solution, and a solution is a value or values that we put in place of a variable that make the equation true. Okay, so let's take a look at example 1. I hope that you paused your video and that you wrote your vocabulary. Let's take a look at example 1. I have 3 plus x equals 7. This is my equation. So first of all, an equation is like a balance beam, because both sides have to be equal to each other. So let's pretend that I have a balance beam here. And on the left side, I have 3 plus x, and on the right side, I have 7. In a balance beam, both sides have to remain balanced. Well, obviously, some number x plus 3 equals 7. So both sides are 7. So what is that number x? If you look at it just by inference, you would be able to know that it's 3 plus an x is simply 4, and that equals 7. 3 plus 4 is 7. So we have 7 equals 7, right? Because an equation is balanced on both sides. Now, this is how we know that x is 4. How? By, well, simply basic addition. But the real challenge here is how to prove this algebraically. So let's go ahead and take a look at our equation. And I'm going to write it down. I have 3 plus x equals 7. So I know that x equals 4, but you want to prove this algebraically. So this is the algebraic way of proving this. So the first thing you want to do is identify your variable. What is our variable in this case? Our variable is x. Now, what do you want to do with that variable? You want to isolate it. You want to make it be by itself, right? So the way that you do that is by doing the opposite of whatever is with the variable. In this case, you are adding 3. So the opposite of adding 3 is to subtract 3. So I'm going to subtract 3. That would be my next step. Is you are going to do what we just called an inverse operation. Step 3 would be do it to both sides. Now, what I mean by both sides, remember the equation sign stands for, like, if you have the balance beam. So the left side is equal to the right side. Now, let's go ahead and do it to both sides now. I did 3 minus 3. Now let me do 7 minus 3. This is a very important step. If you forget to do it to both sides, then your equation is not going to be balanced. In order for it to be balanced, you need to do the same thing to both sides. This is my step 3. Do it to both sides. Now that I have this, let's go ahead and see what we're left with. I'm going to go ahead and close this off, right? Well, take a look at this. I know that 3 minus 3 is just 0. So now I have 0 plus x. And I know that 7 minus 3 is just 4. So this is what I'm left with. Well, if you take a look at 0 plus x, well, what is 0 plus x? This is basically just x. Well, why is 0 plus x just x? Because everything that you add by 0 will simply just be that number itself. This is called, let's write this down. This is called the identity property. Is every time you add a number by 0, like for example, x plus 0, 2 plus 0, 3 plus 0, 5 plus 0, a million plus 0, will always just be that number itself. And this is why we're simply just left with x. And we know that because of that, x is equal to 4. So this here is your solution. And if you notice, there's only one. X, in this case, can only be replaced with 4 and nothing else because 4 will make the equation true. Any other number will make it false. What do I mean by that? Well, let's go ahead and check. I'm going to rewrite my equation. I have 3 plus x equals 4. Not 4, sorry, my apologies. 7. Rewrite your original equation. X plus 4. I'm going to substitute this back in here because x is now 4. So this is now 3 plus 4 equals 7. There's only one number that can be placed in the place of x in order for you to have 7 equals 7, which makes the equation true. If you were to substitute another number for x, and let's say you put 5 instead, well, now you have 3 plus 5. 3 plus 5 is 8. 8 does not equal 7. Therefore, that would make the equation false, right? This is a very simple example where you simply have the variable on the left side and you're just subtracting to isolate the variable. Let's take a look at another example and let's see what the difference is now, because you will have different types of examples. Let's take a look at example 2. Example 2, now I have 17 equals x plus 4. If you notice now, the variable is now on the right side. So that's the difference between example 1 and example 2. Let's write that down. Now the variable is on the right side. Okay, well, just because it's on the other side doesn't make a difference. Everything remains the same. We still follow the same process. Let me start by drawing my little balance beam to represent the balance of an equation. 17 on the left, the balance represents the equal sign, and x plus 4. So both sides equal to 17. Well, in that case, if this is 17, the other side also has to be 17, but you have a number plus 4 equals 17. Well, if you think about it and you do it by inference, you know that that number has to be 13. So it's 13 plus 4, and 13 plus 4, if you add it, 13, 14, 15, 16, 17, indeed does equal 17. So this is 17 equals 17. The equation remains balanced. We know this by inference. However, the true challenge here, or the true task, is can you prove it algebraically? And the way that we do that is by following the steps that we just did in the previous example. So let's take a look at how do we do it algebraically. Now I'm going to rewrite my equation. Here it is. Identify your variable. In this case, my variable is x. And remember, the goal is you want to isolate this. You want to isolate the variable. Okay, great. I got that. Identify my variable as x. I want to leave it alone. How do I leave it alone? I do the inverse operation of whatever is with the variable. In this case, I'm adding 4. So let's go ahead and do the inverse. Let's do the inverse of adding 4. What's the inverse of adding 4? Subtracting 4, the opposite. So I'm going to subtract 4. But remember, you do it to one side, you got to do it to the other side. And I forgot to draw my little line to represent my balance beam. So if I did that, now I want to come to the left side, and I also want to subtract 4. Let's go ahead and do it to both sides. You have to make sure you do it to both sides in order to balance the equation. I'm going to go ahead and close this off. Now, what am I left with on the left side? Well, 17 minus 4 is simply 17, 16, 15, 14, 13. So now we have 13 equals x. 4 minus 4, what is it? You guessed it, it's 0. X plus 0. This is what I'm left with now. Well, take a look at this. X plus 0 just gives you back x because of the identity property. So here we state that this is the identity property. Right? So now we have that, and now we have that 13 equals x, or x equals 13. You can interchangeably switch them around because the equation is the same thing on both sides. So it doesn't matter where it goes on the left, it doesn't matter where it goes on the right. Okay, so this is what I have now. We already knew that, but we just proved it algebraically. Now, the very last step you want to do is now check it. So I'm going to go ahead and do my final step, which is check for my solution, because my solution, this right here, is 13. And remember, an equation only has one solution ever, because there is no other number that you can put in the place of x that is not 13 that will give you back 17, right? So let's go ahead and rewrite our equation first of all. So 17 equals x plus 4. In place of x, I'm going to place 13. So we're substituting x for 13. Now I have 17 is equal to 13 plus 4. Let's add 13 plus 4 real quickly just to double check. 4 plus 3 is 7. And then bring down the 1, that's 17. So 17 equals 17. This is true. This just lets us know, it verifies to us that we have solved for the equation correctly and we are good to go. Okay, I don't know about you guys, but I love solving equations. It is honestly one of my favorite things. Okay, now that we have that, let's go and take a look at another example that's just a little bit different, and let's look at the differences from example 1 to example 2 to example 3. Now we have x minus 3 is equal to negative 12. Look at the differences that we have. Now in this case, if you notice in example 1 and example 2, we were adding. So we were adding x plus 4, or in example 1, we're doing 3 plus x, but now we are subtracting from x. So now we are subtracting instead of adding, and that's okay. No change is going to be made. And then we also have now a negative on the right side. So we were only dealing with positives, but now we're dealing with negatives. Okay, so now that I have this, first is first. Let me go ahead and draw my balance beam just to represent the balance of an equation. On the left side, we have some number, take away 3, is negative 12. So some number, when you subtract 3, will give you negative 12. Well, the challenge is now, what is that number? I want to know what that number is. When I think about this example, I think about a number line, because when you're dealing with negatives, it's a little more abstract, right? You need to think about it a little more closely. So let's draw a number line real quick. My number line here. I'm at some number minus 3 is negative 12. So I know that negative 12 is my final solution. And what I did to get to that number was subtract 3. So I started somewhere. I had to start somewhere. This is my x. I don't know what this is, right? Right now, we don't know what it is. But I started there. And from that point, I subtracted 3. Remember when you're subtracting on a number line and it's a positive? Remember that when you subtract, you're going to the left, right? Because you decrease in value. So let's go from here. Let's go to the left 3 spots. So 1, 2, and I ended up at negative 12. Well, now let's go backwards and let's see what is that number. Let's go ahead and count. This is negative 12. This is negative 11, negative 10. This is negative 9. So that number is negative 9. So let's go and take a look. Negative 9 take away 3 equals to negative 12. And think about it. You started at negative 9. You subtracted 3, so you went to the left 3 units, and that in fact does lead you to negative 12. So we know that x is negative 9. But remember, we need to solve it algebraically now. So let's go ahead and start doing the steps to solve algebraically. I'm going to rewrite my equation. X minus 3 is equal to negative 12. First thing I want to do is identify my variable, which in this case is x. It's not always x. It could be a, it could be z, it could be g, b, f, h, l, o, n, o, p, whatever you want it to be. A variable is just a letter, okay? X is the one that's most famously used, right? But it doesn't always have to be x. So don't get confused if you see a different letter. What do we want to do with that, everybody? We want to isolate it. We want to isolate it. So the next thing that I do now is do the inverse, or do the opposite of whatever is with the variable. In this case, you are subtracting 3. So notice how in the previous examples we were adding. Well, now you have to do the inverse of subtraction, which in this case is addition. So I'm going to go ahead and write this down. Now we're going to do the inverse operation of subtraction, which is addition. So I'm going to add 3. But make sure that you do it to both sides. I'm adding 3. I'm going to go ahead and close off my equation, or so just to organize my work better. I'm going to rewrite the work that I have. So I have x. What does this give you? 0. So it's x minus 0 is equal to, what's negative 12 plus 3? Well, some of you might still have a challenge with doing this. We went over this on, I believe, day 4 and day 5. So let me just draw a quick number line for those of us that still have a hard time, and that's okay, guys. This takes practice. So you start at negative 12. I'm at negative 12, and you are adding 3. When you are adding something, you are increasing in value. Therefore, that means that you go towards the right. So when I do that, I go 1, 2, 3. This is where I end up at. What is that? It's negative 11, negative 10, negative 9. So this is negative 9. Well, now let's keep rewriting. What is x minus 0? X minus 0 is simply x equals negative 9. And the reason for that is because of the identity property. This is the identity property. And finally, we are left with our solution. Remember, there's only one. As we had initially proven, no, we initially stated, but we had not proved it yet, and now we just did. So the final step is to now, you guessed it, let's check it. Rewrite your equation. X minus 3 equals negative 12. In place of x, what are we going to put? We're going to put negative 9 because that was the solution. We're going to substitute it. So now it's negative 9 take away 3 equals negative 12. Well, let's prove that negative 9 take away 3 is indeed 12. Negative 12, sorry, by using a number line. So now you're starting at negative 9. You're subtracting. When you subtract, you decrease in value. So you go towards the left. Subtracting, going towards the left. How many units? We go 3 units. That's 1, 2, 3. We're right here. This is negative 10, negative 11, and negative 12. So now we have negative 12 is equal to negative 12. Is that true or is that false? Well, this is clearly true. Therefore, that means that you indeed have the correct equation. Okay? And this concludes our examples. You will have several of these examples with negatives and with positives, addition and subtraction instead. So in order for you to help you do your steps when you're solving for your Khan Academy assignment, go ahead and take a look at the steps that I provided for you on the team site. So this is the steps that we just followed to solve for our one-step equations. Step 1, identify the variable. That's the first thing we did. We're solving for x, we're solving for a, we're solving for g, we're solving for y, whatever it is that you're solving for. Step 2, isolate the variable using inverse operations. So the inverse of addition is subtraction. If you're adding, you're subtracting. And the inverse of subtraction is addition. If you're subtracting, you're going to add instead. Step 3, do it to both sides. Make sure you do it to both sides. This is so important and when solving for an equation. Step 4, use the identity property to state the solution. And then step 5, check for the solution using substitution. I forgot to mention that. Substitute your solution for your variable and check it. And if you get back that both sides are true, both sides are equal to each other, then the equation is true. Okay, guys, this concludes our assignment for today. Our video for today. Please make sure that you are completing your Khan Academy assignment for the day, and please send me your notes when you are complete. Okay, I will see you all tomorrow. Have an awesome